In this video, I'm going to discuss my implementation of a stack using a linked list. So the end product will be a class called MyLinkedStack that again provides implementation of a regular stack just using a linked list. Let me point out that there is a different video that shows the implementation of the stack using the same interface that you're looking at on the screen, but that video uses an array, and that is called MyArrayStack class, and there is a video where I explain in detail the implementation. So both videos are implementations, one using an array, one using a linked list of the same thing, which is a stack, and therefore they're using the same interface to emphasize the point that given an interface in Java, I can have different ways of providing implementations for the same interface. So this is the typical implementation interface of a stack in Java. I call it MyStack. So it has a method called push, which we're going to use to add objects at the top. We have a pop method, which we're going to use to delete the element at the top. Pick displays the contents of the object at the top of the stack, and is empty obviously answers the question whether or not the stack is empty or not. Then what I'm going to be doing next is to show you a class that defines a node for the linked list that I'm going to create or I'm going to use to implement these four methods while I do the stack. I created a class called myNode, which I have been using to implement linked lists when I need to, and because I'm going to use a linked list to implement the stack, to implement the interface I just showed you, I just want to remind you how this myNode class works. It's basically the most common implementation of a node for a linked list. So this class doesn't implement the linked list, implements just one node of the linked list. So every node is going to have two very important items, two pieces of data, two instances, which are essentially the object that I'm going to store in the node, and I call that data, and then a reference to the next node, which is typically called next. So all I'm doing here is having a basic node that contains an object of any given class and a reference to a similar node in the linked list. So I have a constructor, and the constructor that I chose is my node that requires two parameters. So it's going to require the object that I want to insert in the node, and then a reference that is going to tell me what the next field in this node refers to. And in order to set those two values, I'm actually going to use two of my mutators. One is to set the data and one is to set next. Set the data is down here, and obviously what it does is to take the object that is going to be in the node and sets that to the field called data. And in order to extract that value, I'm going to use the method getData, which typically what it does is an accessor. So it accesses the object, the data that I have on the node. The other two methods are used to deal with the field called next. So one sets next to whatever value I'm passing here. And remember, in Java, the value of a reference is going to be either an address that contains the next node, an object, or null. Okay, so basically those are my two choices, null or a reference to an object. And then getNext is the corresponding accessor for the field next, and that simply tells me, okay, this is the address of the next object in the linked list. So it's a very basic implementation of a node that is going to be used as part of a linked list. So finally, I'm going to discuss the implementation of the stack using a linked list, and I call this MyLinkedStack. So notice that, as I said earlier, this is just implements an interface with four methods that I call MyStack that we discussed earlier. Because this is a linked list, a simple linked list, I only need a reference to the first node. The only change is that traditionally we will call this either front or head, which is the name that typically we use to refer to the first node on the list. But because I'm building a stack, I'm implementing a stack, then I changed the name to be more meaningful. And I said, okay, this is now going to be called top of the stack reference. In other words, it still is a reference to the first node in my list because the first node is the top of the stack. The first node is, or the front of the list, is where the additions and deletions to the stack are going to happen. And obviously, because I don't have anything on the stack, my linked list is empty, I'm going to initialize that reference top of the stack to be null. The method push, again, remember this is pushing an object into the stack, is adding an object to the stack. So think in terms of, this is a very simple operation. This is equivalent to inserting a node at the beginning of a list. So all I have to do is to change the value of the reference that points to the first node of the list. And the first node of the list is called top of the stack references. So because I'm inserting a new value, I need to allocate memory. So I need to call my constructor. And as we discussed in the previous document, I need two parameters. One is the object that I want to insert, and the other one is what is the next field going to refer to. So at the beginning, top of the stack reference is set to null. So when I create my first object, my first node, that is going to have an object as part of the field that I call data, and then the reference will be null because the list was empty. So all I'm doing is, again, adding a node at the beginning of the list. The method pop, again, is used to remove, and what I'm going to do is to remove the first node of the linked list, which is a very simple operation. So my first step is to verify that I have a list. If the list is empty, meaning I don't have a stack or the stack is empty, then there is nothing to be deleted and I need to throw an exception. If the list is not empty, this expression is false, then I'm going to go to my else, and in the else, what I need to do is basically copy locally into an object called result the current object at the top of the stack, the first node. Why is that? Well, because I'm going to return the value that is deleted. So temporarily, I'm going to store it in a local variable, and then at the very end, that's what I'm going to return. After I store the current top of the stack, then I proceed to change. I proceed to delete the first node on my list. I proceed to delete, to remove the node that is at the top of the stack. And how do I do that? Well, by advancing my references. So I'm going to change top of the stack reference, which currently points to the first node on the list, to point to or to refer to the second node on the list. And that's very basically what I need to do in order to delete the first node. So to summarize, push is a simple insertion at the beginning of a linked list. Pop is a simple deletion at the beginning of a linked list. The other two methods are pick and isEmpty. So the method pick simply says, let me display the contents of the first node. And again, I need to check for empty list. If that is the case, I'm going to throw the same exception. If the list is not empty, then I know that I have at least one node. I need to display that. And based on the discussion of the class myNode, I know that there is an accessor called getData, which retrieves the object stored in the second node, and then I return it. So it's a very simple operation. Display the contents of the first node in my linked list. And finally, I need a Boolean method isEmpty that returns true if the list indeed is empty. When is the list empty? Well, when the reference that looks at the first node, top of the stack references, is equal to null. So this is going to be either true or false. It will be true when the list is empty, false otherwise. So as you can see, using a linked list to implement a stack is very simple. The methods are very short, very concise. This is the end of the discussion. And again, if you haven't done so, I encourage you to watch a video called My Array Stack that uses an array to implement the stack using the same interface called MyStack.